Hello, this is Anthony, and welcome back to another episode of the Advent of Code. Today is day 2, and we'll be looking at the inventory management system. As always, if you want to play along, you can check out the puzzle yourself at adventofcode.com/2018/day/2. Alright, let's jump into the problem. Again, I'm paraphrasing because there's actually a lot of reading on the website. Today, we're trying to find some magic fabric for Santa, and it's in a bunch of mystery bins in a warehouse. These bins have IDs, which are strings of characters, and we'll be solving some puzzles around those. The first problem, we have to make sure that we have the right set of bins, so we must compute a checksum. Though, we're only given one set of bins, so I guess it's more of a sanity check. Of these bins, we have to count how many IDs have exactly 2 of any letter, and how many IDs have exactly 3 of any letter. Then we'll multiply those together to get our answer. Here's the sample data that we're given. I've annotated each ID to show what it's matching. Also note here that we can't double count any ID, even if it has a character that would have been counted twice. In this example, there's 4 things that have 2 and 3 things that have 3, so our overall answer is 4 times 3 equals 12. Again, this video spoils my approach to the problems, so if you'd like to try them out yourself, pause here and then continue when you're ready. As before, I'm going to describe my approach in words, and then we'll jump into a more technical description of the problem. This part is a pretty straightforward linear solution where we check each of the lines. The tricky part here is determining whether a line qualifies as a 2 or a 3, or both. Beyond that, we keep track of the counts, and at the end we multiply them together. One hint that can make the implementation in Python simpler is to use the counter type. A counter takes an iterable and returns a dictionary-like mapping which counts stuff. We can use this to count characters in our box IDs. Unlike day 1, I'm going to try explaining these solutions in pseudocode, and I'll leave translating it to a language of choice as an exercise for the viewer. If you want to see my solutions, you can check them out on GitHub. In this case, the loop and check approach is pretty straightforward. For each line, we make a counter and record whether it counted something twice or 3 times, and then at the end we multiply them together. While I was streaming this last week, a follower proposed this other solution in chat, and I thought it was interesting enough to share. Theirs was written in Elixir, but here's the pseudocode for this approach. In this, we convert each line into a sequence of characters, and then progressively subtract out the unique characters, and with that, we know how many were multiples of 2 or 3. We have to go one further to make sure that it's not a multiple of 4. After that, we do some set math to make sure there's at least 1, 2, or 3. I thought this was clever because it doesn't actually use a counter at all. It's not any more efficient though, in fact it's probably a little less so, but clever nonetheless. Okay, on to part 2. I was surprised when I got to it, and it was quite different from part 1. In fact, we weren't really going to be reusing any of the code from part 1. In part 2, we're told that the 2 boxes containing the fabric have almost the same ID, except one character is different. This is commonly referred to as having an edit distance of 1. Here we have our sample input for part 2, and we can see that the 2 indicated lines only differ by the 3rd character. And the problem asks us to find the common characters, so our answer is FGIJ. Again, spoilers if you want to pause here. As for some Python-specific hints to this one, there's a useful function called zip. What zip does is it takes 2 iterables, well, actually as many as you want, and will continually yield the nth element from each iterable. This makes it easy to iterate through a bunch of lists at the same index at the same time. I use this in one of my solutions to compare lines against each other. The first solution that I came up with is, in my opinion, the more straightforward solution to the problem. Basically, we just compare every box ID with every other box ID. I saw a bunch of other people's solutions which did largely the same thing, and the only main difference was how they compared the 2 lines together. Here's how I compared lines. I looked through each character and recorded the ones that were the same. After that loop, if the length of the same characters was the same as the length of the lines minus 1, then I knew that I had found the solution where there was only an edit distance of 1. While we're on the subject of this solution, there's a tempting optimization to sort the input lines and then only compare against the neighbors. And while this solution is much faster, and as far as I could tell for my dataset it worked, I ended up finding quite a few cases where sorting would produce the wrong answer or no answer at all. So I've left that approach out of the video. One particularly clever solution I saw was to use the Python standard library module difflib, which can be used to compare strings. My sneaky solution involving difflib counted the number of caret characters to see if it only differed by 1, as you can see in this example. Oddly enough, this falls apart for very short strings, as difflib just doesn't tell you about their differences. In an effort to try and improve the runtime of the algorithm, I tried thinking of a different approach. In this approach, as we loop through the lines, we keep track of all possible line substrings that we've already seen, and if we encounter one we've seen before, then we're done. This reduces the outer loops from O of n squared to O of n times O of m. In this case, n is the total number of lines and m is the length of the strings. This means you end up with a faster runtime if your strings are short, or you have a large number of lines. However, it trades off space for time. You need to keep track of a bunch of things that you've already seen. And that's all I've got for day 2. If you want to follow along live, I'll be streaming some of these on Twitch, and if you want to check out my solutions in Python and other programming languages, you can find my code on GitHub. Thank you all for watching, and have a good one!